In this session, we are going to discuss about three-phase bridge inverters. Three-phase bridge inverter is a six-step bridge inverter, six-step inverter actually. It uses minimum a six number of switching devices. It can be thyristors or it can be IGBT, MOSFET, etc. We will do the circuit diagram and discuss the working. So for drawing the circuit diagram, I'll draw it with a thyristorized circuit. So this like this, okay. We'll be having 6 thyristors like this. The DC source will be connected here. This is your DC source voltage, say Vs, source voltage. And these thyristors, let it be marked as T1, T3, and T5. The upper group elements or positive group elements, and the bottom ones we marked as T4, T6, here it is T2. And this, from these terminals, we'll connect the load from here. Okay. Here we'll be connecting the load. Okay. Let this be your three-phase load. Can be a motor or any load. Okay. And let this. Connect the terminals like this. And the terminals, let it be A, B, and C. Okay. So this voltage will be your VAB. This will be your VBC. And from here to here, it will be VCA. Okay. And if it is purely resistive load, only these thyristors will be functioning. As we had did it in the case of single phase bridge inverters, here also we have to connect the feedback diodes. So feedback diodes always across the thyristor like this, anti-parallel to that. Across the first thyristor, it will be D1 connected anti-parallel to it, like that. So I will put that also here. Okay. That is your D4. This is your D5, and here also one more diode across it, which is nothing but D2. Okay. So this is the circuit diagram. Now we will see the working. Okay. So there's basically this three-phase bridge inverters can be classified into two, as one is called a 180-degree mode of operation. Second one is called the 120-degree mode of operation. The circuit is the same. The circuit is a three-phase bridge inverter circuit. This is the circuit for a three-phase bridge inverter. And the operation mode actually varies by varying the switching pattern. Circuit is the same. Okay. This is a thyristerized circuit. So here instead of T1, T3, T5, we can connect etc. T6 we can connect instead of thyristors or SCS we can connect transistors or IGBT, etc. Okay. Now we will see the working. For that we'll be triggering. First, we'll be discussing about 180-degree mode of operation. Okay, 180-degree mode of operation. 180-degree mode of operation will be using or will be switching the devices in such a way that each SCR will conduct for a duration of 180 degree. Okay. So each SCR will conduct for a duration of 180 degree, and there are SCRs, there are 6 SCRs. One top layer SCRs are called the positive group. Positive group are the elements being marked are T1, T3 and T5 from the upper group or positive group. And the lower group or the negative group elements are negative group SCS, or the lower group SCS are T2, T4 and T6. Okay. And it is given the naming in such a way that the same leg, in the same leg, this first leg will be having T1 and T4. In the second leg, it is having T3 and T6. Third leg, T5 and T2. Okay. And we'll be switching the SCS at an interval of 60 degree. Each SCR will be triggered at an interval of, each SCR will be triggered, means triggering will be given at an interval of 60 degree. And each SCR will conduct for 180 degree. And your T1, the triggering pattern will be T1, T2, T3, T4, T5, T6, like that. Each with an interval of 60 degree. Means T1 will be triggered first. After 60 degree, T2, after 60, T3, then T4, then T5, and T6, and T1, T2, like that it goes. Okay, that is the triggering pattern. So let us see the circuit diagram again. In the circuit, let us copy it. Here you can see the circuit. In this circuit, you can see here will be triggering in such a way that we need the output voltage as ABC. If we need the output voltage sequence, output voltage, we are expecting a three-phase output voltage. Okay, if the three-phase AC output, the sequence, if we require it in this fashion like A, B, C, the sequence, if it is A, B, C, will be triggering T1 first. Then after triggering T1, after 120 degree will be triggering T3. Then after 120 degree will be triggering T5. Then after 120 degree, the cycle repeats. Okay, that will be the from the positive group. Okay, and from the negative group, we'll be doing like T2. Once T2 is being triggered, after 120 degree, will be triggering T4. After 120 degree, will be triggering T6. Then after 120 degree, we're triggering T2, like that. That pattern continues from the lower group. Okay. But each SCR will conduct for a duration of 180 degree. Okay. So we can have 6 different steps in the operation with like each SCR will try to draw the pattern or divide the 360 degree into 6 steps of 60 degree duration. Okay, let us draw the triggering pattern and waveforms then. Okay, the triggering pattern, let us start from here. Okay, let this be our 0 degree line, and for the so let this be our 0 degree point. Okay, now this is the 0 point. Now after an interval of 60 degree, will be triggering the next SCR. Now we will mark the angles first. So this is our 0 degree, then 60 degree, 120 degree, 180, 240, 300, 360. Like that it goes. Again repeat 60, 120, like that, no? And the steps we can write it as a steps as, so this is our first step, second, third, fourth, fifth, sixth, and again repeats 1, 2, like that, 3, etc. Okay, now let us see. First will be triggering T1 here at 0 degree. Let us trigger T1. Okay, T1 is being triggered here. Okay, and we know that it will continue till, as we mentioned earlier, each SCR will conduct for a duration of 180 degree. So let this be our point, 180. So till here, T1 will be conducting. Okay, T1 will be triggered at this point and it will continue till 180 degree because this is our 180-degree line. This is 180 degree. Okay. Now we'll be triggering T2 at an interval of, after triggering T1 at an angle delay of 120 degree, we'll be triggering T2. Okay. So here will be our T2, and again it will conduct for next 180 degree, it will be conducting. Okay. So this will be T2. And T3 will be triggered after 120 degree. You know that it is a three-phase sinusoid, three-phase AC output voltage we require for a symmetrical three-phase waveform. We need three-phase quantities being apart by 120 degree. So T1, then, sorry, this is your T3, not T2. Sorry. T1 is triggered at 0 degree, then T3, as I mentioned earlier, once T1 is triggered, here, once T1 is triggered, after 120 degree, we'll be triggering T3 like this. Okay. And then after 120 degree, we'll be triggering T5, and that pattern continues. So I'm going to write it here. So now at 0 degree, I have triggered T1. I'll be triggering T3 at after an interval of 120 degree, and T5 after another interval of 120 degree, and each one will conduct for 180 degree duration. Okay. So this will be conducting till here. Okay. So T1, T3, T5 we have shown. And once T1 is, you know that it is 360 degree. So of this 360, T1 will be conducting for first 180 degree. And from that same leg, in this, you can see T1 is in the first leg. This is your T1. And the remaining time duration, T4, which is the counterpart of T1 in the same leg, no, that will be conducting. So once T1 is off, means T1 will be off at here. So at that time, T4 will start conducting for the next 180 degree, completing the 360 degree. So T1, then T4. Once T1 is being switched off, T4 will be start conducting, and that will continue for the next 180 degree. So total 360 degree. So like this, T1, here T4, then comes T1, repeats like that. Okay. And okay. And here now T3 is conducting from here to here. So afterwards it will be T6. And before also, here also it will be T6. No. So T6, T3 will continue for the next 180 degree. So this is 60, 60, here it comes. Okay. And next T5 here. So T5, when T5 is off, as per the circuit, when T5 is off, you can see. When T5 is off, you can see that T2 will be conducting here. No. Okay. So once T5 is not there, T2 will be there. Okay. Here it will be T5. Okay. Here it will be T2 again. And here it will be T3. Okay. So what do we observe? You can see that in the first group elements, the elements or the devices 5, 6, and 1 are conducting. Because 5 is conducting here, here 6, here 1. So 5, 6, 1 will be conducting in the first 0 to 60 degree duration, or step 1. And in step 2, it will be 6, 1, 2. And step 3, it will be 1, 2, 3. Here it will be 2, 3, 4. then 3, 4, 5, then 4, 5, 6. Like that it continues. Okay. This is 5, 6, 1, and 6, 1, 2, 1, 2, 3. Like that it goes. Okay. So what happened is, at a time, 3 devices will be conducting. You can say the conclusion like, at a time, how many devices will be conducting? 3 devices will be conducting. Okay. And each device will conduct for a duration of 180 degree, and will be giving the triggering pattern. In this triggering signal will be given in the pattern like, here you can see will be triggering your T1 here, this T1 triggered here, then you can see this T2 triggered here, right? So that will be at T2 here, then here, and the next step you can see here, no? What is this? This is your T3 triggering point. Then this point will be your T4 triggering point. Then this, no, at that point it will be triggering T5. Then here it will be triggering this here, 300 degree. After 300 degree it will be triggered T6. Then here it will be triggering T1 again. Like that it goes. So we'll be giving the triggering signal in the order T1, T2, T3, etc. with an interval of 60 degree. And 3 devices will be conducting at a time. And so these 3 devices, if we look into, if in the first step, if T1 is conducting, I said T1 is conducting, at that time 5 and 6 are also conducting. Okay. So 5 is this device, okay, and 6 is this device. So 2 from the positive group and 1 from the negative group is conducting during step 1, 0 to 60 degree, as we have marked here in the diagram. Okay. As here. Okay. 5, 6, 1 is conducting, no? 5, 6, 1. Okay. So 5, 6, 1 conducting means, here I could see, clear? It is 2 from the upper group and 1 from the lower group is conducting. And in the next step, you can see it is 6, 1, 2 conducting. 6, 1, 2 conducting means, what is 6, 1, 2? Where it is, you can see 6, 1, 2, no? So this is your 6. The 6 already started conducting, that will continue. The 6 will continue. 6 will continue. Then the 6 will continue. Then 1 will also continue. Newly joining device will be 2. At that time, T5 will be removed from the circuit. T5 will be off from step 1 to step 2. Step 1, T5, T6 and T1 were conducting. In step 2, T5 will be removed out of conduction, but T2 will be added. Okay, so it will be 6, 1, 2. And in the next step, 6 will be removed, but T3 will be added. So 1, 2, 3. So in the second step, you can see the rounded red square, round, you can see 6 and T6, T2 and T1 are conducting. 1 from the upper group and 2 from the lower group. So every time 3 devices will be conducting. 1 from positive group, 2 from negative, or else 2 from positive group and 1 from negative group. And how the output voltage will come, we just see it now. Okay. Now let us analyze the working with the help of a 3-phase symmetrical load. The impedance in each phase for the is Z. Okay. The load terminals are A, B, C. Okay. And Now I have shown only the thyristor circuit. Okay. Now feedback diodes are not being shown in the diagram. That's all. For our easiness, let us assume that the load is a resistive load, so that feedback diodes won't be working. And now for the resistive load, for step 1, let us do that exercise for we made it for step 1. Let it be step 1 means 0 to 60-degree interval. Okay. We have already denoted it as during step 1, the devices that are conducting are 5, 6 and 1. Okay, the devices that are working are 5, 6, 1. Means this device T1 will be conducting. Okay, means this is on. Now T5 is also on. Okay, this is also on. Then the next one will be 6. No, so this is the 6. This will be on. Okay, so the circuit we can redraw as the elements T1 and T5 conducting, means the source voltage will be, which will be connected, will be Vs now to this. So from this is our Vs terminal, plus Vs terminal, and this plus Vs terminal, it is now connected to this through T1. T1 on means this terminal is connected to A. So this is your A terminal, and it is also connected to this is a closed conduction now, no? And this is connected to the C also. A and C are this plus Vs will be coming at this terminal A, plus Vs will be coming here, as well as here also plus Vs will be coming, and the minus terminal will be coming here. Here it will be minus Vs. I can redraw the circuit like with the impedances Z. Here also it is Z, and this is the O terminal, the center point. I have connected a 3-phase star load with the central point being shown as O. Okay, and this negative Vs is being connected to this the third terminal, which is was your C terminal, this was your B terminal. The same circuit from here I can come to here. Okay, and this is Vs, and if a current I1 flows through this, what is the net impedance here? The impedance, this is Z, this is also Z, and this is Z. So the net impedance will be this Z, two impedances parallel, Z parallel Z, no, it will be Z by 2, and that plus another, it is connected in series to this. So the total impedance will be, or else we can find I1 as Vs divided by the total impedance. Total impedance will be Z plus Z by 2, no? So it will be 3 by 2 Z. So this will be 2 by 3 into Vs by Z. That will be I1. If we know I1, that I1 will be flowing through it. So I1, the first parallel combination, if the current I1 is flowing, what is VAO? This was your O terminal. So VAO will be equal to VCO will be equal to I1 into Z by 2, no? So that will be I1 into Z by 2. So that will be same as Vs by 3, no? I1 is 2 by 3 Vs by Z. So that Z and Z will get cancelled. 2 will get cancelled. So it will be Vs by 3. And what about VBO? VBO will also be, means VBO is negative of VOB, and VOB is nothing but I1 into Z, no? So it will be 2 by 3 Vs. That is again minus 2 by 3 Vs will be VBO. Okay. So this we can mark it as this potential will be Vs by 3 up to here, and from VOB it will be 2 by 3 Vs. So that will be the phase voltages which we are getting. Okay. And the same thing repeats in the next step also. Let us consider the step 2 again. In step 2, we know that in step 2 means 60 to 120 degree. During that step, our devices that are on are 6, 1 and 2. So when 6, 1, 2 are on, let us do it. So in step 2, you see that 6, 1, 2 are conducting. So I'll draw it. This is the 6, 1, 2 I have highlighted. Devices 6, 1 and 2. So here you can see 1 from the upper group and 2 from the lower negative group are conducting. So the voltage waveform, how to obtain the voltages across each, will rearrange this equation, the circuit like this is your plus Vs. This plus Vs is connected through T1 to this A. Through T1 it is connected to A, and your minus Vs is connected to minus Vs is connected to, this is your Vs, minus Vs is connected to, through T6 it is connected to B, and through T2 it is connected to C. No. So B and C, and there is the Z here. This is your B, and this is your C terminal. And in A, there is an impedance Z, a phase. This is your O. So in the same fashion, we can analyze it. So this is your impedance Z, load impedance. Phase per phase it is Z. Okay. And so in the same fashion, we can analyze the current flowing through this. And that also you can see that it is this resultant of this is Z by 2 plus Z in series. So in the net 3Z by 2. Okay. So we'll get the current as Vs divided by 3 by 2 Z, or else 2 by 3 Vs by Z, as in the case of step 1. Okay. And finally, you'll be getting it as the output voltages across each phase. This phase you'll get it as say 2 by 3 Vs, and that is AO. Is it VAO? VAO, you'll get it as 2 by 3 Vs, and this voltage will be 1 by 3 Vs. In the same way, you can write. So VBO equal to VCO equal to minus Vs by 3. And in a similar way, we can find the step 3 also. And I have written that step 3, 120 to 180. It will be, the devices will be 1, 2, 3, angle 120 to 180. So here again, this will be equivalent to the circuit is very much equivalent to your A and B from the upper end now. No. So this is your VA terminal, and VB also, as 1 and 3 are connected, A and B, the devices will be conducting is the upper group elements, upper group devices. Okay, so this is your plus minus Vs, this is your A terminal, this is your B terminal, and C here, and this is O. All are having impedances Z. So now we can say this voltage will be Vs by 3, and this will be 2 by 3 Vs. We can say VAO equal to VBO equal to Vs by 3, and VCO will be equal to minus 2 by 3 Vs. So these inputs will try to draw the phase voltages. Can continue it for step 1 to 6. The same pattern will continue, but we can infer from if we are able to finish say 1 to 3, we can easily anticipate what is the remaining voltages. So I'll try to draw the voltage waveform now. Okay. So I'll draw the VAO now. Okay. Let this be your VAO, and we have found that now we will try to make a table with different steps, step 1, step 2, etc., so that it is easy for us to draw the waveform. Okay, I'll draw the step now, table now. Now I'll try to draw the table with the modes, say 1, 2, 3. Modes are mode 1, you know that it is 5. The devices that are conducting are 5, 6, and 1 are conducting, and the output voltages we have obtained as VAO as equal to, you can see that now. We have seen it now. VAO is equal to Vs by 3, and the VBO is equal to VAO and VCO are Vs by 3, and here it is there, minus 2 by 3 Vs, VBO. Okay. So mark the first step. The second step will pick like from here. VAO is 2 by 3 Vs, and VAO it is 2 by 3 Vs, and VBO and VCO were minus Vs by 3. Okay, and in step 3 it is 1, 2, and 3 switches are conducting, and we have seen that it is here, it is step 3 now. Step 3 it was VAO and VBO Vs by 3. Here it is. Here also Vs by 3. This is minus 2 by 3 Vs. And in a similar fashion, we can fill it up. So this much section I will try to draw here. Okay. So Vs by 3, it was like VAO was like, here it was, initially it was Vs by 3. And in the next step, it was going like 2 Vs by 3. Then it is coming down to Vs by 3. That was VAO. In a similar way, we'll draw VBO and VCO. Let this be our VBO and this be our VCO. Okay. Now with this input, we can extend it to like make the 6 steps there. You see that this waveform will be simply repeating in the same cycle like this, and it increases to minus 2 Vs by 3, then decreases to minus Vs by 3, then coming to 0, then moving to the next step. It will be repeating that. Here it is the same way. This your 360-degree over here. No? So for the first 360-degree, here it is Vs by 3. Here it is 2 Vs by 3. And coming to Vs by 3, then minus Vs by 3, minus 2 Vs by 3, minus Vs by 3. And that cycle repeats. And VBO will be exactly the same as VAO, but it is shifted by 120 degree. This is your 120 degree angle. No. So from here onwards, it will be exactly the same as the VAO, like this. It was here it is coming to 2 times Vs by 3, then coming down to Vs by 3, then minus Vs by 3 here, then it is minus 2 Vs by 3, then coming down to say minus Vs by 3, like that it continues. And if we draw the VCO, again it will be like here it is again shifted by 120 degree, means here the positive cycle will begin. No, here it is the 240 from this end. It is 240 here from the starting end. Should come. No. So that is like this. We'll be repeating like this. From here onwards, there will be VAO same as VCO. Means VAO is being shifted to 240 degree. Then what we get, it is VCO. Like that it goes. Okay, this will be your Vs by 3, and this will be minus Vs by 3. This is minus 2 Vs by 3. Like that. Thus now the single phase phase voltages of the 3-phase inverter is being drawn. Okay, let us complete this VAB also. What is VAB? VAB is nothing but you can write VAB as equal to VAO minus VOB. No? So VA minus VB will give you VAB. Now VA is Vs by 3 here. VB is minus 2 by 3 Vs. So Vs by 3 minus 2 by 3 Vs. So it is plus. No. So we'll get it as Vs. Okay. And VB, what about VBC? That is VB minus VC. No. So this minus this will give you minus Vs. What is VCA? VC is Vs by 3 minus VCA, VA. VC minus, this is nothing but VC minus VA. This is VB minus VC. So I'll get it as 0 here, right? And in the second interval, second step, again this will be Vs, and this VB will be 0. This will be minus Vs, and in third step, VAB will be 0, because VA and VB are same, so this will be 0, and VBC will be this minus this, so it will be Vs. This will be minus Vs. So let us finish the entire table. Now the table is finished. Now we can draw the line voltages. Line voltages, it is nothing but VAB is VA minus VB. Now I'll try to draw the line voltage waveform. Okay. So this is here Vs. Then it was 0 for the next duration. It was Vs. Then 0. Then in the third step it was 0 itself. Then next, this is your Vs. It's 0. Then comes the plus Vs. Like that it goes. Okay. So this will be your output voltage VAB. During this band it is there. And this voltage is magnitude of it is, say, Vs. This is Vs. And this is minus Vs. Okay. This is your output voltage, line voltage waveform of the output load. Okay. Now we will draw the line voltage waveform VBC. And it is, the elements are being marked in the table. So it was starting from minus Vs, then 0, then Vs, Vs, like that it goes. And while drawing, we can find it that this is, say, minus Vs, it was minus Vs, then coming to 0, then going to plus Vs. Okay. Then coming to 0, then again minus Vs for two steps. Like that it goes. So the output voltage is this thing. Output line voltage. Okay. While observing, you can find that this was your VAB, which was at the step 1, it was 1 Vs having a magnitude. Here now you can see it is being shifted by 120 degree. After 120 degree, the same VAB repeats here. Okay. And similar the case with the VCA also. It will be shifted by again 120 degree. Means this is your 240 line. From there, it will be starting like. Okay. So here that also can be understood from here also. It is 0, then minus Vs, 0, Vs it is going. Okay. So the 0, then coming to say minus Vs. Then it is coming to 0, then to going positive, then 0, then negative, like that it goes. Okay. So these are the line voltage waveforms. or if it is a delta load, only line voltage is applicable there. And these were the phase voltage waveforms. Here you could see line voltage is constant. If line output is there, it is Vs constant as Vs, the same supply DC input. Intermittently, there is a zero lines there. Okay. And this shows the table. Okay. So this, so far we were discussing about the 180-degree mode of operation. Okay.